Hello everybody, my name is Conrad Diaz. I am the president of Cognetics Mechanical Engineering Academy. The video that we bring to you today is a product engineering design review of a camera, slider, and dolly. Now, a product engineering design review in this case is a design evaluation of an existing product from an engineer's perspective. We have our product right here that we're evaluating today, and as I mentioned before, it is a camera, slider, and dolly. So as you may have guessed, this kind of product is used by people in the photography and video world. What they do is, if you can picture them using this, one of the ways that they would be able to use it is by attaching an accessory here. It's a threaded stud, so we have to turn until the accessory is fully connected and secure. And we're going to tighten this as well. And this is just an example of one of the accessories that could be attached to such a product. Do it this way, right here. So now if you can imagine, this accessory happens to be a mount for a cell phone. So you would put your cell phone in here. This is spring-loaded, and it would hold your cell phone securely. Now, what you're able to do is, as you are taking video, you gradually and slowly pan from one side to the other. The end result is a very, very nice video with a panning effect. And of course, you can go both ways. I imagine that some photographers use it also to zoom in and out. If you have a camera facing that way, and of course, you would have it steady, not the way I'm holding it, but you're able to approach and get farther away from your subject. Okay, so that's what a slider is used for in the video world. This is the slide functionality, and now let's talk about its use of the same product as a camera dolly. In the case of a camera dolly, the slider function would be fixed. So we turn this knob here. This no longer moves left and right, but the entire product, if we loosen this up for a moment and retract the feet, so the entire product would be riding on the wheels, on the four wheels that you see here. Okay, those two are off. What I'm doing here, just so you can see, I am loosening these up and I am retracting the stands so that the wheel will engage the floor or the surface that this camera dolly is riding on. Let's see if that's enough. Yes. So in this particular case, this is the other functionality of this product, is to be used as a camera dolly. Now, like I said, the slider is fixed. This no longer slides left and right in relation to the rail. The entire product moves left and right, which is the dolly function. So you can slide your camera longer travel, basically. Okay. Another thing that you will notice, I'm going to show you real quick, and we'll go into more detail later. We can go ahead and turn these. Let's turn them this way. You can change the angle on the wheels. So now, if you are videoing something on that side over there, you are able to take the camera around it in a curved path. Okay, so it's a fun product. Things that people, like I said, in the video world use. But our intent here at the Academy is not to evaluate this product from the perspective of a video, of the end user, basically. The end user is somebody that's into video and photography. That is not why we're evaluating this. This is the Mechanical Engineering Academy. We're evaluating this product from an engineering perspective. This being the Cognetics Mechanical Engineering Academy, we're more interested in what we can learn from the design, the pros and cons, with the end result being that we learn more about its design, its engineering, the reasons behind certain decisions that the product designers made. Okay, so let's go ahead and notice a couple more features of this product. You notice that there are 4 feet, okay, here in orange, 1, 2, 3, and 4, okay. Now, the feet are adjustable, so if you have an uneven surface, let me do that, let me get it back on its stance here and off the wheels. Okay, I think that's done there. These 2 as well. Okay, so right now it's off the wheels, so it's behaving as a slider again. So if we loosen up the brake, we have the slide functionality with a steady rail. However, you can imagine that somebody uses this out in the field, perhaps at a park. They set it down on the ground, on dirt, on a rock, on grass, I don't know, what have you, right? So it may, you can foresee a situation where it does this kind of a thing. Just like at a table at a dining room, right? Where the floor is not even or the 4 legs are not flat and in contact with the floor surface, you're gonna get this thing going on here, okay? Because 3 points define a plane. 4 points is redundant. That's why we run into this situation often. If you have a table that has 3 legs, it does not do this. It never does this because 3 points define a plane. In any case, the feet are adjustable. So if we turn this and it makes contact with the surface, it is now stable. It does not rock back and forth. It does not wobble. Okay, so that's a nice feature of this design. We also have the ability of this product to be mounted on a tripod. So here we have threaded holes. Here's a I believe it's a 3/8 of an inch size internal thread, and this is probably a 1/4-20 internal thread for different tripods. So if you can imagine a large stable tripod and you mount the slider onto the tripod, now you have a stable setup with slide capability, and it is elevated off the floor. Okay, so let's go ahead and move on now. Let's move on to the next topic. Okay, before we move on, we have to give credit what credit is due. I'm going to go ahead and remove this, but I want to make sure that we address what product we're evaluating, the brand, the model, etc. So this product is made by Tarion. I hope I'm pronouncing it correctly, Tarion. And it is a camera slider and dolly, and the model number is TRSD60. So TRSD60. I believe the 60 stands for 60 centimeters long. Okay? All right. As you can see, there are some reference videos that I'm including in this video. You can go ahead and look at similar products to this one so that you understand the functionality, and you can start to do a little bit of research on your own and understand what the options are. Other products have similar features, but they're not identical to this. So it's very good for us to go ahead and compare against other products because it puts us in a position to learn from different options and perhaps understand the trade-offs that the designers made in designing this product. Okay, as you know, when we're designing a product, there are several factors to consider during development. You can see a list on the screen right now, and that's, believe me, that's just a partial list. Quite often there are a lot more factors that are relevant during development that we need to take in consideration as we design these products. In our particular case for this review, we're going to cover some of the factors only, such as functionality, reliability, durability, perceived quality of this product. Not the quality itself, but note that we're calling it the perceived quality. Also, we'll touch on aesthetics. Of course, design for manufacturability, or DFM, which is a very, very important aspect of all product and system design and development. And we'll talk a little bit about how some standard components were integrated into this product and why those decisions were made. Okay, now let's go ahead and go over the main components of this product. First, we have the track, which is this long component here. It can also be called a rail. All right. We have lifters. You can see 1, 2, 3, 4 lifters. If we turn the knobs, the entire product would lift off of the surface. Okay, so we're calling those lifters or supports. Those are used in the case when this is a slider. This product is being used as a slider, in which case it is stable. The lifters are in contact with the surface, and the only thing that moves is the slider itself. Okay? The other function of this product, as we have mentioned already, if the slider is not active, if it's secure in relation to the rail, we now have wheels. So the entire product would slide left and right, rolling on the wheels. Okay? Another thing we're going to touch on is what kinds of fasteners were used to join these sub-assemblies and join and assemble the entire product. Okay? Here we can see socket head cap screws. There's one here, there's another one here. Different kind of screw right here. 4 of them for the rollers. Here we have thumb screws. But in general, here's another socket head cap screw, which is consistent with the practice for fasteners and joining components that are metallic and machined or cast. Okay? The types of fasteners that we use for machined products are different, usually, from the types of fasteners that we use for plastic injection molded products. Okay? And you can go ahead and look on the Academy's website at www.mechanicalengineeringacademy.com. We have other videos that more specifically address the types of fasteners used, why they are chosen, the pros and cons of each, and how to properly specify them and how to properly design them as far as engineering drawings, etc. Okay, let's go ahead and move on. Okay, let's go ahead and talk about the track or rail for this product, which is this long component here onto which the slider travels. Okay, so material-wise, let me secure this so it doesn't keep moving around for now. Material-wise, it is likely that the product engineers decided to make this out of aluminum. 2 typical material types used in this kind of product are steel and aluminum. Now, steel is heavier, so aluminum is lighter, is strong, and it does the job in this particular case. So one thing to keep in mind is shipping costs, for example. It's going to be a lot more expensive to ship a product made out of steel, which is heavier, than a product made out of aluminum, being lighter. So most likely, the material we're looking at here is aluminum. Okay. Not only that, the user, the end user likes and enjoys. We always enjoy products that are lightweight. Okay. As far as straightness, obviously this is a rail. We have a carriage or slider that travels. We have a video camera mounted on this rail. We do not want it to be rocky. You don't want your video to go like this, unstable and wobble as it goes along the length. So it'll kill the panning effect. So from an engineering perspective, they probably specified that this rail needed to have a specific level of straightness. Okay, and in other videos in the Academy, we talk about how we go about specifying that on the engineering drawings. As far as the manufacturing process, I'll take it apart in a moment, but you can already tell that the rail is fairly consistent as far as cross-section. If we were to cut the rail right here and look at the end view, we would see a cross-section. Okay? That cross-section is fairly continuous or constant throughout the length of this rail. Okay? When you have such a part that you need to design and produce, quite often it makes sense to go ahead and make it an extrusion. That's the manufacturing process. So the tooling will have an opening which is shaped in the cross-section profile that you're after, and the material will be extruded through that opening. So the end result is that the entire length of the material will have a constant cross-section profile. Okay. Now, of course, that's not enough. If they had done that and stopped there, the product that it would not work yet. Okay. There is some post-machining that takes place. You have an extrusion that does not have any holes. It does not have these curved ends right here. Okay. It'll be, if we just cut an extrusion, it'll be sharp at the end. So they needed to design some post-machining operations onto this. For example, the threaded holes. Those are added after the material has been extruded. These curves at the end, they're most likely post-machined. The extruded material does not come out that way. So they post-machine it to give it the geometry and provide the mechanical features that they need for mounting and so forth. Okay. As far as treatment, what we mean by that is, what do you do to the material after it's been produced? Okay. So when you extrude an aluminum piece like this, obviously you're going to end up with a raw aluminum finish. Which is usually light gray, right? Some sort of shading gray. For aesthetic reasons, they decided that they wanted this to be black. As it turns out, aluminum can be anodized. It's one of the treatment finishing processes that are an option for aluminum. So one possibility, and again, I don't know this for a fact because I haven't looked at the engineering drawings of this product, but one possibility is that they black anodized the aluminum. Okay. In the case of black anodizing, they're not painting it black. It's a different process that we also talk about in the Academy in other videos. Okay. They could have black anodized it. Regular black anodized does not necessarily create a harder, tougher surface on the aluminum. But they could have also chosen to hard anodize it, which is a different specification, which you can also color black, which produces a much tougher surface. Okay? Finishing, well, if they didn't black anodize it, if that's not what we're looking at here, they probably coated it or painted it in some way. Again, I'm not looking at the engineering drawings, so I don't know exactly what they did to the rail and the other components. Okay, let's talk real quick. If you notice, carriage moves and it stops at the other end. It would not be a very nice user-friendly product if the slider moved and then kept going and fell off the rail, and it could damage your camera. It wouldn't serve the purpose. So the way they accomplished the end of travels here, they added a hard stop. So this plastic component limits the travel of the carriage. I'm going to go ahead and remove it quickly just so we can see what that looks like using an Allen wrench, removing the probably quarter 20 socket head cap screw that they used here. Quarter 20 socket head cap screw. Okay, removing, whoop, there it goes. The hard stop. Hard stop was originally installed like this. Okay, I slide it off to the side, and you can see the end profile geometry of this extrusion. And you can see that this hard stop matches that profile, like this. So very nice design in that respect. This hard stop is made out of plastic. Obviously, you can see that it's injection molded. Okay, you see some features there, some details, you see some cavities. If you want to learn more about injection molding design, again, please visit mechanicalengineeringacademy.com. We have videos that will share some of this information for you. And eventually, we will have programs, certificate programs, to teach you, if you're interested, how to do mechanical design, either of machine components or plastic injection molded products. Okay. Okay, now let's go ahead and talk about the support assemblies, or sub-assemblies, shall I say. Support sub-assemblies are these components that have been sub-assembled, and there's two of them, one on my left, one on my right, and they lift the rail off of the surface. Okay, so obviously we notice that it's got wheels. Each of these wheels looks very much like a rollerblade or skateboard kind of a wheel. Okay, we'll talk about the wheels in more detail a little bit later. Okay, now let's talk about the lifters. Okay, if we look at this here, let me set this down this way, and we can talk about the lifters. Okay, so what we have here are thumb screws that you're able to turn. Now, as I turn clockwise, the foot is going to go farther away. Okay, right-handed rule for threads. Turning clockwise extends the screw downward. Obviously, going the other way is going to lift the screw, the foot, I'm sorry, so that the wheel engages the surface instead. Okay, now, being that this is relatively professional level equipment for video camera people, and their end purposes, they don't want this to rattle and move. You can probably tell that if this screw is not tight, it wobbles. And you can imagine that the whole thing is going to wobble on a camera, and that may be that wobble may be revealed and affect the performance of your video. So what they have provided here is lock nut. This one down here is a lock nut that spins separately from the thumb screw. So I'm going to go ahead and do that. I'm going to hold the thumb screw, and I'm going to spin only the lock nut. And you can see it going downward. And if you spin far enough, you're going to go ahead and make contact with this hexagonal surface here, which serves to lock not only the capability of being able to turn this thumb screw, but it removes the play of the assembly. So now you have a very stable foot that's not going anywhere. Okay, same thing on all four sides. You have thumb screw and lock nut. Okay, they all work the same way. The feet, another thing we can notice, well, I don't think you can tell, but I'll go ahead and describe it for you. The tip of the foot is made out of flexible material. It's an elastomer of some sort. Most people would just say it's rubber. However, rubber is sort of specific. There are many types of flexible materials that do not qualify as rubber. So what I'm going to call it, to be a little bit more accurate, is an elastomer material, which is elastic, it's flexible, but it doesn't, we don't know without looking at the engineering drawings or the bill of material exactly what material that is. But you have a soft point, you have 4 of them that contact the surface that you're setting this product onto. Okay, another thing we'll notice, and let me go ahead and remove one of these support sub-assemblies. Okay, you will notice that this support sub-assembly is held in place by this 3-arm lock nut. 3-arm lock nut, because it locks it into place. Gonna go ahead and remove that, turning counterclockwise. So basically this is simply a lock nut. It's like a knob, but in this case it's got 3 arms. Ergonomically speaking, it's very easy to turn and tighten this kind of a geometry. If it was a round geometry, it would be a little bit harder to tighten. Okay, so I'm going to put that aside for now. And let's go ahead and look at this assembly. First thing that after the lock nut comes off, we see that there's a washer. Okay, washer is going to protect and make this whole securing and joint more reliable, smoother. Okay, so remove the washer for now. We're going to take out this support sub-assembly that comes with the wheels. Okay, we'll talk about that in a second, but before we go ahead and talk about that, let me point out that here there's an elastomer washer. Again, I don't like the term rubber because that's a bit specific. It could be an elastomer of some sort that does not qualify as a rubber. But you can see that it's flexible. Okay, it's just a washer made out of flexible material. And I imagine that the intent behind that, since this is adjustable as far as angles, and then you secure it again, having a flexible component right there keeps this from squeaking. Once you expose it to forces, if there's no elastomer material, it could turn a little bit and squeak and make a sound. Again, that's going to affect your video recording. So they want to keep this entire product as quiet as possible. That is one of the main reasons for having this washer right there. Okay, I'm going to go ahead and remove it just so that we can keep dissecting this product. Put it down there for now. All we're left with is a threaded stud, but it is not fixed. It actually turns, and the reason it turns is because it is simply a socket head cap screw that has been threaded in there. So let me give you this angle here. So you can see we have a socket head cap screw threaded into the rail. That's the construction of the support. Now, looking at this sub-assembly, it's simply a sub-assembly of a hexagonal axle is metallic, of course. The thumb screws that we already talked about, and the wheels that we talked about. Okay, let's move on for now. Talk about some other things. Okay, let's go ahead now and talk about how the wheels are integrated into this product. So not only the wheels, but also we have other standard components that have been integrated into this product. Now, what we mean by standard component is it's a component that already exists. Sometimes it's called off the shelf. You can go to a website, you can go to a company, and you can buy these products. They have already been designed and they're already in production. Okay? Quite often it makes sense to go ahead and include standard components into your product rather than reinventing the wheel per se and reinventing all the components, the screws, the wheels, the bearings that go into your final product. That does not make sense. It's a lot faster to develop a product if you integrate existing components and you only design what needs to be custom designed. So in this case, my guess, and again, I don't know for a fact, but these wheels look pretty standard to me. I imagine that some company already produces, they already have designed and produced these wheels. And they provide engineering drawings with their wheels. So the designer of this product, Tarion, their engineering team, sourced these components. They looked at the engineering drawings, and they integrated them into this product. Okay, so that's for the wheels. Obviously, you can see here ball bearings. Ball bearings we'll talk about in more detail in some other videos that we're putting together, but they're very common components. They're intended to reduce friction between rotating components. Reduce or almost practically eliminate friction between rotating components. What you can't see here, because they're covered, inside this ball bearing, there's tiny little spheres or bearings. They're called ball bearings. They're spherical in geometry. And there's a bunch of them all the way around the bearing. And what we have what we call the inner race. See if I could get a little bit closer. Inner race is that cylindrical sleeve made out of hard metal that I'm pointing to. This is the inner race. This is the outer race. So between the outer race and the inner race, you have the ball bearings. So if you can imagine that as the outer race spins, the ball bearings are rotating inside the bearing subassembly around the inner race. So there's virtually no friction in ball bearings, okay? And you get this very smooth, stable rotating motion between components. The washers here, I really doubt that any company is going to go ahead and design washers. They just locate them, spec them or specify them in their bill of material, in their mechanical design, and they go ahead and integrate it. Now, a big part of the reason why there's a washer there underneath this screw is so that the washer applies pressure to the inner race. So the inner race is fixed. When the wheel rotates, inner race is not turning. And we accomplish that by tightening this screw through the washer, applying pressure onto the inner race. That secures the inner race all the way to here. So from this end to this end, the inner race of the bearings, which there are two, there's another one here, do not rotate. The outer races of both bearings rotate with the wheel. Okay. Again, we're going to have plenty of videos at the Mechanical Engineering Academy that teach you how to integrate ball bearings into products and machines. I encourage you to go ahead and look on our website, become a member for free, and you'll gain access, instant access to a lot of this very interesting mechanical design material, training material. Last thing I'm going to mention about this is what we call a button head cap screw. Okay, right here, I'm going to turn it this way. You can probably see right there the geometry of the screw. It's a little bit like a mushroom. It's like a mushroom head. In machine design, in this engineering industry, that's what we call a button head. And it's a cap screw socket drive. Okay, it gives you a very smooth surface that's not going to hurt anybody. It looks fairly nice and it's secure. Okay, and again, we have videos that talk and provide you training on how to choose threaded fasteners for your products and systems. Okay, now let's talk about one of the most interesting aspects of this product, in my opinion, which is the carriage or the slider design. Its motion is very, very smooth. And part of the reason is the design that the engineers used in the rollers of assembly here. It's very secure, very smooth. The rollers virtually eliminate friction between the rail and the carriage of assembly. The brake design is very nice. It's secure, set in place without damaging the rail. Before we look at that further, though, let's talk about compatibility with accessories in the industry. It appears that in the photography and video recording industry, as far as accessories and their connection, there are two types of threads. I believe there are 1/4-inch threads and 3/8 of an inch thread. So, for example, this completely separate product that I showed you before that holds a cell phone has a 1/4 of an inch threaded connection here. That directly goes here, and we get a secure, stable connection between these two different products. Because in the industry, 1/4-inch is one of the standards. The reason I bring this to your attention is that when you're designing a product, you have to understand the industry and what your products need to be compatible with. In this particular case, Tarion knew that a lot of the accessories that they have to be compatible with are 1/4-inch threaded. They also knew, however, that some accessories are 3/8 of an inch. And that's why they provide this separate, this separate accessory over here. It's not an accessory, it's basically an adapter. Internally, it's 1/4 of an inch of a thread. Externally, 3/8 of an inch. So the way it works is, very simply, you thread this onto the existing fixed 1/4-inch thread until it bottoms out. And now you're left with 3/8 of an inch connection for your other accessories, okay? Very clever, very simple, not very costly, and the end users will really, really appreciate this. Now, I just threaded it by hand, but you can see that they have a slotted connection there, a slotted slit for screws. A slotted screwdriver could tighten this as well. Okay, I'm going to go ahead and remove this. Now, here's one very important detail. Anytime you have a product and something is removable, it's also what I call looseable. I don't really know if that's a word, but what I mean is you remove something of a product, you put it here, you put it somewhere else, you forget, next time you know you lost it. And the entire capability of your product is diminished because you have lost the accessory that was removable. Product designers, we have to think about such things. Whenever possible, either the removable component is somehow attached to your product, let's say it had a string and it just hangs off to the side, you cannot lose it because it's connected with a string. Okay? In this case, that doesn't make sense because it would be rattling, it would hit metal to metal, it would make noise, and that would affect the quality of your video recordings. So another option that does make sense in this case is to provide for example, guess what? 3/8 of an inch threaded hole here. So if that's not being used for a tripod that happens to have a 3/8 connection, we can very easily thread our adapter in there simply for storage purposes. Now, it cannot be lost. It's attached to the product itself. Whenever you need it, it's there. Okay? And of course, it does not interfere with the function of the product. Very nice feature, very clever. I like that aspect a lot. Okay, let's go ahead and talk about other details of the carriage design. We have, once again, an elastomer pad here. Most likely not only for aesthetics, but probably the main reason is to eliminate or minimize noise. So we have an elastomer here. Whenever you attach something to it, there's not going to be any squeaking or rattling kind of noises. Okay, the elastomer absorbs the noise. And it also helps create a secure connection between components. Okay, looking a little bit closer here, we see that Tyrion, not only do they have their branding identification here, but also here on the carriage. Okay, very nice, nice color design, shiny. Want to point something out though. Mechanically, if you look underneath, we have the brake. This is the brake assembly. Okay, this block here holds the brake, which is obviously a threaded component. Okay, clockwise locks it. This is an elastomer pad so that we don't damage the rail. Counterclockwise loosens it up. Okay. However, this block itself is not physically a part of the carriage block. It's a separate component. What that tells me is that they have attached this small block for the brake to the larger carriage block with screws. Okay, but they're not visible down here. There's no screws that are visible from this end, so they must be coming from the other side. You would think that there's a screw. Let me take a larger screw just to get the point across. Much smaller than this, from here downward, and it is holding that block. Okay, but we cannot see that. Reason being that the designers were clever enough to have the screws there. There's probably 2 of them underneath this. I'm not going to go ahead and remove it, but there are probably 2 socket head cap screws or screws of some type under this pad. And to help the aesthetics of the product, they cover it with a branding component. I thought that was a very, very nice touch. All right, let's see what else we have here. Let's go ahead and talk about the rollers. Very interesting design, very nicely done. I'm going to get this screw out of the way, and I'm actually going to go ahead and remove the carriage off of the product so that we can have a closer look. Okay, so we've got the carriage here on the rail. I'm just going to go ahead and slide it out all the way. Okay, set this down for a moment. So now we've got very nice looking carriage. By the way, we're talking about aesthetics. This is most likely, well, I would think, don't know for sure, but it could be anodized. If this is aluminum, which I think it is, there's not only black anodized, but you can actually anodize in any color you want, any color that's available for that matter. So they chose to orange color anodize this piece of aluminum. It's my guess. We don't have access to the engineering drawings. But in any case, talking again about the roller design here. So we have 4 rollers, okay? We know that there are manufacturing tolerances. Every part, when you specify a dimension to it, it's not perfect. Okay, let's say this width here is designed to be 3 inches. Okay, when it's manufactured, it's never going to be exactly 3 inches and every single time. There's going to be a manufacturing tolerance to it. Sometimes a little bit larger, sometimes a little bit smaller. Okay, the tighter the tolerance, the more accurate it's going to be. But there is a manufacturing tolerance nevertheless. Okay, so the reason I bring this up, this carriage design fits very, very nicely here. If you're able to see it, I cannot wiggle this in any kind of way. It's secure. Okay, so we ask ourselves, how is that possible? If there is a manufacturing tolerance between the axes of these 4 rollers, let's say from here to here, let's say it's supposed to be 2.75 inches. Okay, but there's a manufacturing tolerance. If it's a little bit closer, it's going to be too tight. It's not going to go in, it's not going to fit into the rail. If it's too loose, then the carriage is going to rock. It's going to be loose on the rail. How did they manage to secure it so nicely without any kind of play? The answer is right here. The 2 rollers that are up here, these guys, have a fixed axis. The axis does not move. However, the rollers on the other side, you can tell, let me zoom in a little bit closer, it's a slotted hole. Okay? That tells me that these 2 axes for the rollers below, we can move the axis closer to the rail and farther away from the rail. So it's an assembly process. The design has adjustability. When they assemble the rail, during assembly, they tighten the axis, they bring the axis closer, and they bring the rollers in contact with the rail, and then they tighten the rollers into position. Very nicely done. This kind of thing is done in machine design, mechanism design, and of course, product design. Okay, it's another one of the topics that we cover in the academy. Okay, I'm actually gonna go ahead and disassemble this because I want you to see a little bit more detail how this is done. You'll notice here holes that are for set screws. Okay, the set screws are what is used. It's the means that the designer chose to bring the axis closer to the rail. So let's go ahead and take that apart for a moment. If I have the right tools here, I should be able to disassemble this. One of these actually was already loose before. Let's see. This kind of tool provides a lot more torque for disassembly purposes. Okay. So once it's loose, I think I can proceed with a regular screwdriver here. Okay, that is loose now. What about this one? I'm going to pause for a moment. Okay, I have the right tools now. Well, close to the right tools. This hex tool here is going to keep the screw from spinning while I undo the other side here. Okay, it's coming off. All right. I think we're there. Can go the rest of the way by hand. There we go. Okay. So what we have here, the roller has come off. The roller has this threaded component that acts as the axle the axle of the bearings, of the roller itself, okay? I'm going to set this down for a moment. So let's pull it out. Okay, very nice fit there. It was not loose. Again, we want to minimize or eliminate noise if we can. So axle looks like this. It's basically a slotted component on one end so we can drive it and torque it down, and an internal thread. Okay, this goes through the roller. The roller here itself has a bearing on one side and another ball bearing on the other side. So two bearings create this rolling motion. We have the axle that goes through there. Okay, then we have to secure it on the other end. Now, before I show you the other part, remember when we talked about bearings, there's an inner race and an outer race when we're talking about ball bearings. Inner race, of course, is the smaller diameter race. It's a sleeve, cylindrical in shape that you can see turns. And then the outer race is the largest possible diameter in contact with this probably nylon roller. And in between the inner race and the outer race, we have the ball bearings. So very, very low friction, efficient way of producing rotary motion. Now, keep in mind though, since we have an inner race and an outer race, let's say the head of this fastener was large and it was as large as the outer race, it would create a conflict. The head of the screw itself would prevent the bearing from functioning properly. So the diameter of this bearing is large enough, but not too large. Put it back in. So it's designed to only hold the inner race. It keeps the inner race from spinning. Okay, on the other end, knowing that, we need a component that will contact the inner race, but not the outer race, so that it spins properly. So when we look over here at the other end of this axle design, put the roller down. What do we have here? Yes, as you can see, there's a washer. This washer right here is sized to contact the inner race of the ball bearing and enable proper function. So putting this down again, the head of the screw on this side contacts the inner race and locks it in position. This washer contacts the inner race of the other bearing at the other end and locks both inner races together so they're not rotating, but the roller is rotating along with the outer races. Okay, I hope that makes sense. Yet another topic that, another mechanical engineering and design topic that we cover in the academy. In a lot more detail, of course, with engineering drawings and CAD modeling. Okay, now on the other end, we were talking about adjustability of the axis. So you can see from this end, we have a slotted hole, this end as well. So the axis of the screw can move out and in. We have it all the way in, and we have it all the way out. Okay? So you can imagine how this whole thing, you have an axis there, you have a internal thread here, you thread that in there, the whole roller is secured. Okay, they went a step further. Rather than relying on manual assembly or some other method, in here they designed a threaded hole for a set screw. So when you assemble all of this, let's look over here. I don't know if you can see it with the camera, but right there is a set screw. If I tighten the set screw, it's going to push the axis inward. If I loosen the set screw, the axis is going to go out. It's going to loosen on the rail.